is 0 there, isn't it? Y'all see the correspondence? The slope of the tangent line on the red curve at this point corresponds, that number right there corresponds to the y value of the blue function, the output of the blue function. Let's do another one. Let's pick an x value. Let's pick this x value right here. Okay, whatever it is. Let's go to the red curve right there. What would y'all say about that slope of that tangent line? Do y'all like my tangent line drawing? Does that look pretty tangent to you? Yeah? What about the slope of that line there? Is it 0? No. Is it positive or negative? It's positive, right? That's a positive. So we should expect to see a positive slope there? Yes, the derivative here, the derivative at that point is some positive number. Another way to say that is that the derivative is greater than 0, right? If I tell you something is greater than 0, I'm telling you it's positive, right? So we all agree that the derivative at this point is positive. So that means if I go look at the derivative function, the blue one, the y value of that blue function should be where? Above the x-axis, right? Positive. So if I go up to the blue function, notice that that point, whatever that number is, it looks like it's a little bit less than 4, yes? What we're saying is that the slope of the tangent line right here is a little bit less than 4. Make sense? Let me do another one. Let me go back here, pick a value here. Go there, slope of the tangent line there. What can you tell me about it? The slope would be negative, right? So I'm going to go less than 0, which means if I go look at its derivative, the derivative's y coordinate should be below the x-axis. So go to this x value, go to the blue curve. See that y value is down here. It's a negative number. Show of hands right now. How many of you feel like you kind of are seeing the connection? I just want to see where we are. Okay. Anybody need clarification? Yes?
On the y-axis, that would be the slope you said, wherever that question mark is by 4, that would be like the slope.
Whatever this number is, let's just say it's 3.75. Okay? That number 3.75 would correspond to the slope of that line right there.
Oh,
okay? So the red curve has a bunch of tangent lines all over the place. And if we go to a certain point and want to know the slope of that line, all we have to do is go look at the derivative function, go to that same x value, and then go get the y coordinate off the derivative, and that'll give us the slope.
Okay, I get it. Thank you.
Yeah, this is like the big deal about the derivative. It always gives you the slope of the function it came from. Let's try another example. For this one, I think what I'm going to do is I'm going to make up my own. And this time I'm not going to write the function f of x down. I'm going to draw it, and then I want us to see if we can draw its derivative. All right, so here we go. This is where things start getting interesting with your ability to understand. All right, here's the function. Let's start with something really simple. Wait a minute, my scale's not right. Let me get back to the home version there. There we go. All right, so what if I draw this function? It goes like that. These are straight lines. Okay, that's not a curve, that's a straight line. I'm going to tell you, oh, you know what? Hold on, time out. I did the original function in red, didn't I? I'm going to do that again. I want to stay with the same colors. Okay, so the original function goes like this. I'm going to say that that's the function f, all right? There's the drawing of your original function f. The instructions here are to sketch f prime. Sketch the derivative. So that's what the original function looks like. I want to know what its derivative looks like. So what I'm going to do here is I'm just going to see if I can't get myself started. Let me go to some particular value of x. I'm going to go to -1. and I'm going to go up to the function here, and I'm going to go to that point, and then I'm going to think about what is the slope of the tangent line there. So what do y'all think the tangent line looks like if you have a straight line? Do you think it's flat here? No? What do you think the slope of the tangent line would be here? Negative? So do you all agree that the slope of the tangent line should probably be just the slope of that line? Like the tangent line should just be that line right there, that little piece. That makes sense to you? Can you tell me the slope of that line right now? Close. Not 1, not positive 1, negative 1. How do you know? Can you tell the slope of this red line? You go down 1 over 1, don't you? So the slope of the red line is negative 1, down 1 over. So the slope of that black line should also be negative 1. So let me draw the derivative in blue. I know that when I draw the derivative, when I go to negative 1, the y value, right, the y value of this blue function should be negative 1, which is down here. Oops, sorry. Oops, I answered that. I meant to hit hang up. Okay. So the y value, right, at negative 1, the slope of that is negative 1, so I should go down and plot a point down here at negative 1. That's part of my derivative. That's what part of what the derivative looks like. If you didn't understand that, let me go to another point. Let me go to this point right here. Let's go right there at a half. Okay? If I go there, what's the slope of the tangent line there? Still negative 1, right? Still negative 1. And so my derivative function, when I go to negative a half, sorry, should come down to same value, negative 1, shouldn't it? Isn't that going to be the case for every point that I pick over here? No matter what point I pick? If I pick some point here, right, plug it in, the slope of the tangent line there is going to be negative 1. And so the blue would be negative 1 there. And that works all the time, right? So my curve, my derivative should look like this, shouldn't it? Always. My derivative should be negative 1 when I'm over here. What if I go to the other side? Say we pick this point right here, 1. Plug it in. What's the slope of the tangent line there? Positive 1, right? So now what am I going to do is I'm going to go here, and now I'm going to draw the blue curve, right? And it's going to be up at positive 1, which happens to be the same point, which is weird, but that's what it is. What if I go to, let's say, 1/2 right here? Go up here. What's the slope of that tangent line there? 1 again, right? So my blue curve at 1/2 is up here at 1. What if I pick any point over here? Go up, slope of tangent line is 1, isn't it? So I draw my blue curve, it's going to be 1. And it should be 1 all the time over here. Yeah? Now, there's one point I have carefully avoided, and that is 0. So if I ask you, what's the slope of the tangent line at 0? I think a lot of you would probably be comfortable saying 0, right? The slope would be 0, but there's an issue here. There's a sharp corner, and we're going to learn here in this section that when you have sharp corners like that, the derivative does not exist. There is no derivative here. There's no tangent line at a corner. So the way I'm going to do that in my, let me say a different way. If I try and do that limit, okay, if I try and do that limit at 0 for this function, I'm going to get undefined. The limit will not exist. So what I'm going to do is I'm going to put an open circle here and an open circle here. And so that what you can see there, the blue that you see there is the derivative of the red one. All right, let's see a show of hands this time. How many of you feel comfortable with what I just did? Uncomfortable? It's okay. Little bit. We're going to do more, okay? We're going to do more examples. So let's try another one of these, all right? And when I do this, you need to pay attention to the slopes of these little pieces I put up here, because they're They're important to you being able to get your answer. So how about this? I'm going to draw the original function in red. Let's have it do this. Oops. That doesn't look right. I'm telling you that that's a straight line, okay? That's supposed to be straight as well. This is the function f. I want you to sketch the derivative. All right, sketch the derivative of this. So let's start with this piece over here, right? This piece here. This is a straight line segment, right? So can y'all tell by just looking what the slope of this little line segment is? Rise over run? So if I want to go from this point, let's say from this point right here to that point right there, what's my rise? To go from here to here, I have to rise by how much? It's kind of a trick question. I'm not really rising. What am I doing? I'm going to move down, right? So that's a rise of -1. That's a negative. So you go -1, that's your rise. And then your run is 2, right? So on this line segment, if I were just looking at line segment, that line segment has a slope of -1 over 2, -1/2. That's the slope of that line segment. What about this line segment? Can you tell me what the slope is here? So if you want to get from this point to this point, how much do you have to rise by? 2, and then run this way? 1, right? 2 over 1 is 2. And then what about this one over here? If I want to get from this point, let's say, to this point, I rise by -2 and run by 2. So the slope here would be -1. Y'all got that or not? I'm getting these looks of deer in headlights a little bit. You don't see, understand this? Okay, that's just me noticing what that function's doing. Now I'm going to go try and find the derivative. All right, I'm going to try and draw this derivative. So to draw it, let me just pick some point over here. Go up to it. I should do some black. Go here to some point, go up to it. All right, right there, slope of the tangent line is the same as the slope of that line, right? So it should be, when I draw this thing in blue, I'm going to draw where? From here, what? Down how much? 1/2, right? Down 1/2. So I'm going to go down 1/2, which is going to be about right there, and I'm going to put a dot. Pick another point. Let's say here. Do the same thing. What's the slope tangent line there? Well, same as that slope. So I'm going to go to that same x value, come down, draw -1/2. And I do that for all the points over there, right? For every point over here, it's going to be -1/2. So it's going to look like this. Right? A line is just a bunch of points, right? That's all it is. So now I'm going to look at this piece from here to here. From there to there, if I pick some x value in here, right? And I look at the slope of the tangent line, that slope is 2, right? Is 2. So when I plot my derivative, I should go to this x value, go up to 2, and put a dot there. Do a different one. Here, go in here, slope of tangent line there is going to be 2 as well. So at that same x value, I'm up here at 2. And that'll happen between here and here. I'm always going to get 2 to come out for the derivative, right? So I have a little line segment that looks like this. And then finally here, no matter where I pick, yes? Yeah, I'm going to come back and do that, but you could do it right now if you wanted to. You could just do open circle here, open circle there. Because there's a big jump like that, you can do that. Yeah, I'm going to do it. Yep, I was going to just draw this one first, then do the open circle, but I'll do it right now. This will be open circle. And then, yes?
So basically it just goes off of the slope of the line to where we draw the point.
Yes, when we have graphs like this F is straight line, straight line, straight line, then it's just go off the slope.
But if it's a curved
If it's curved, I'm not ready to give you that yet, 'cause we're building up to that, because right now we just want to understand the relationship, right? It's going to be harder with a curve, right? Because we're not going to be able to actually know exactly what the slope is. So it's going to be harder. Here, for this piece from here to here, the derivative should always give us -1, right? So I'm going to come down here, -1. This should go like this. And I'm going to draw an arrow because this arrow keeps going. That implies this continues. And then I put an open circle like that. This in blue is the derivative of that function. Does that make it is that a little better? That help a little bit? I think there's a problem in your homework. It just looks like a W. Like the graph they give you is like a W, and it's basically this idea. Okay. Any questions? I'm going to move on to the next example. Well, you know what? Before I do this one, I'm going to show you this other one that I've got ready. Check this one out. I'm giving you the graph of a function, right? And we're going to want to take a look at what its derivative looks like, all right? But to do this one, I'm going to just, because it's not straight line segments, right? These are not straight line segments. I can't tell you that the slope of the tangent line is always the same, right? On the little segments. There's gradual changes happening with the derivative, right? So I'm going to move a point across this curve like this, from left to right. I'm going to move that point. And as I move the point, I'm also going to draw you the little tangent line. See the little tangent line? And this right here is giving you that value. That's giving you, the computer is actually giving you the slope right now. So do we all agree that that slope is just a little tiny positive number, right? Not tiny, but it's positive, right? There's a little bit of a pitch to it. So 0.48, that seem reasonable to you? That that's a derivative there? If I move to the right, right now, if I move to the right, what's going to happen to that value? Is it still positive? Okay, is it a bigger number or a smaller number? What do you think? Is the slope going to get steeper if I move to the right? Yes? Steeper means a bigger number, right? So watch what happens to this number as it moves to the right. Ah, look, it's getting bigger, isn't it? Because it's getting steeper. And then we get to this weird point right around here. It's about 3.4, 3.5, somewhere in there, right? And what's going to happen if I start moving to the right now? Is it going to continue to stay positive? It's still positive right now, right? But it's going to start getting smaller again, right? Until I get to this top point right there, and then what's the derivative there going to be? 0. See that? So we're trying to understand this behavior. Let me move this thing back. Let's move to the bottom of this. Look at the very bottom, isn't the derivative 0? It's somewhere there, I can't get to it, but see it's 0 down there? And then to the right, it's positive, it gets bigger and bigger and bigger, it means steeper and steeper and steeper. And then it kind of like levels out, not levels out, but it kind of maxes out as big as it gets, 3.35 or something. And then it starts to, that derivative value starts to get smaller, but it's still positive. And then we get to the top, the derivative is 0. What happens when I move to the other side? Now it's going to be negative, small negative number, but it's going to start to become a bigger negative number because it's like a steeper descent, right? Until I get to this weird point right around here, I'm still going to be negative, but now the negative numbers are getting smaller again, right? Going back to 0. Y'all see all that together? Now let me show you, what the hell is this? Oh, I don't need that. Now what I'm going to do is I'm going to have the computer draw the derivative as I move across. It's in green, okay? So the green graph is the derivative. Notice that right here at the bottom, right? What did we say that the slope was here? 0. And notice that the derivative, I'm not quite there yet, but do you notice the derivative is going to have a y value of 0 there? And then as I move to the right, I should see that green graph go above the x-axis because my derivative is positive. It kind of like maxes out right there, right? That's the steepest I get. And then it starts to come back, still positive values, until I get back to 0, flattens out. Now I should expect small negative numbers, getting bigger and bigger negative numbers. I kind of max out the negative numbers, start going back to small negative numbers, and back to 0. That all kind of... So, original function, derivative function. What's the derivative going to look like for this one? That's the original function. What can you tell me about this? It's a straight line, right? So the slope should always be whatever the slope is. I'm going to tell you the slope is 3, okay? The slope is 3 all the time, right? That means the derivative should be what? 3 all the time. What is that going to look like? Horizontal line, right? You go to any point on this curve, say, hey, what's the slope of tangent line there? It's always 3. That's why the derivative is always 3 at every single point I ever pick. Yeah? I'll give you another one. Ooh, this is an interesting one. I want you to look at it for a minute. Let's see if we can do this ourselves. We'll do it on here. Is there anywhere on this graph that anyone in this class can tell me for sure they know what the value of the derivative is at that point? What do you got?
At 0,
At 0, everyone look at the x value 0. Do you all agree that the slope of the tangent line there should be 0? Do y'all see it here? Right there. Doesn't it look like that slope is 0 there? Right? Right at that point. So do we agree? At 0, we should have the derivative, right? Should be 0. So that blue is part of my derivative picture. What about to the right? Who wants to tell me what's happening to the right? As I go to the right, what is this slope of the tangent line doing? Who wants to? Go ahead.
Increasing, so it's becoming a bigger positive.
It's becoming a bigger positive number. So it starts out going to the right, we're at what? Small positive numbers. And they start to get bigger and bigger because it gets steeper and steeper, right? So when I draw the derivative in blue to the right, I should start with small positive numbers and then get bigger positive numbers, right? So it'll almost look like a little parabola over there, right? I don't care exactly what the values are. I just need to know like the general behavior. Who wants to tell me the other side? What's happening on the other side of this? And just do it by going backwards. If I were to go backwards, what's that derivative? What's that slope? So who wants to? Go ahead. If I start moving to the left a little bit, what do I got? It is steeper, right? But are these slopes positive or negative? What's the slope of a line that goes like? It's positive, right? It's positive. So when I draw my derivative, if I start moving this way, I have small positive numbers that are becoming bigger and bigger positive numbers, aren't they? So when I draw my derivative this way, small positive, getting bigger positive, which should look like that. I'm going to bring in my little thing here. Where's my point? It's coming. There it is. Okay, so my point's way down here. Look at that. This right here is a very steep positive slope, right? So my derivative should be a very big positive number. In fact, it's not even on the graph. It's off the graph somewhere. But do you all see that our derivative is a big positive number here? And then as I move to the right, just look at what happens. That slope is still big, but look, it's starting to get smaller. Still positive, though. Do you see the derivative coming in here? Right? And it's small, getting smaller and smaller positive, and then we get to 0, it comes flat, but then it goes back to positive again, right? And stays positive and gets bigger positive. The steeper the derivative, right, the steeper this slope is, the bigger the positive number you get out for the derivative, right? The steeper negative, you get a big negative number out. Let's try another one. Your homework is going to be where you're going to be given a bunch of graphs of functions, and then you're going to be given a bunch of graphs of derivatives, and you have to match which function goes with which derivative. Does that make sense to you? On a test, that's not what you get. I don't give you a match on the test. On the test, I give you a function, I ask you to draw its derivative, which we'll do. We're going to practice more of these. All right, what about this one? Give you a moment to just think about it. By looking at this, does it ever look to you that there's a point where the derivative is 0, where you actually have a flat tangent line? What do y'all think? No? I don't see it either. I think no matter where you are on this graph, you're always going to have a tangent line that's got some little pitch to it, right? So there's no like nice point we can go to get this graph started, right? So I'm going to go somewhere that I think I have some idea of what the derivative is. I'm going to go right around to this point, right around here. I think the slope of the tangent line there is about -1. Would you all agree? Like the slope of that looks to be that it goes down the same amount it goes over. So that means that the derivative at this point would be -1, which would be down there. See, I'm trying to give myself somewhere to start drawing this derivative. You know, by that? Now, as I go to the right, okay, as I go to the right to draw my derivative, you know, over here, what's happening to these slopes? They're what? Well, are these positive? Look at your slope. Is that a positive slope or negative? This is positive, right? That's 0. This is negative, right? So that's still a negative slope, right? Still negative? Still negative? But what they're trying to, like they're negative, 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 negative. When I do this, they're all negative slopes, right? But they're getting smaller. So as I draw my derivative, I should be drawing numbers that are negative below the x-axis, but they should get smaller, so they should actually get closer to the x-axis. So my derivative should look like this. Each of these points represents the slope of that tangent line. Small negative, right? If you go way out here, you're going to have a line that's almost flat, right? It's almost flat. It's a little bit of a downward slope to it. So it's just a tiny negative number, which is what this represents, right? Now, how about if I go right here? Right? Now what do I have? It's a steeper slope, positive or negative? Negative. So I should expect to see a big negative number, right? So when I draw this derivative, when I'm right here on the x, I should have a big negative number, right? Down here. What if I go a little bit further to the left? Like right here. How about that? Shit, it's almost wanting to be vertical, right? Hold on, just like, it's almost vertical, right? That's vertical, it's just still a little bit off, right? If you have that, that's an extremely steep negative, right? So that's a huge negative number, which means that I have a point corresponding that x value right there. I have a huge negative number way down here, right? Do y'all see what's happening? What do we have there? What do we call that in college algebra? See, it's an asymptote. We have a vertical asymptote. It's like this, right? What's happening at 0? What's happening at 0? You have no graph, right? And if you have no graph, you have no derivative. So we should expect to see nothing for a derivative through the y-axis. We need the other half. So let me go over here. Again, I'm going to pick a point that I kind of have some reference on. This right here looks to me to be about -1 again, right? That slope is about -1. So I'm going to plot -1. At that x value, I'm going to plot -1, which is right about there. Which way do y'all want to go, left or right now?
Left.
You want to go left? Okay, so if I'm here, let's say, tell me about my slope. Positive or negative? What is it? Negative slope, right? Negative slope at that point. And is this slope going to be, this one's steeper, right? That one's steeper than that one. So that's a bigger negative number than this one. So I should expect to see a smaller negative number here. As I go to the left more, these are still negative slopes, but they're getting smaller and smaller and smaller. The further I go to the left, the smaller they get, but they're always negative. So it looks like this. And then what about if I go to the right? I go here, 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 here. Right? What's happening? Steeper, 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 steeper. Always negative though, right? So that should look like this. Do y'all understand what I was saying? This is like a light bulb thing. Like when you see it, you see it. When you don't see it, it's like, what the heck are you doing, right? Show of hands. How many of you are okay with this? Following? Yes? Okay. Hey, none of that. None of that. What's going on here? Oh, I know what's going on. There we go. Take a look at that graph. Who wants to give me some like verbal description of what are you seeing about this derivative? Like, is there any characteristics that you can tell me? Like general characteristics that you can say about the derivative of this red function. Like, can you tell me whether or not the derivative is always positive or negative? It's always positive. Everyone see that? No matter where you are on this graph, your slope's always positive, isn't it? From all appearances, that's what it looks like is happening, right? So we should always have a positive derivative. Also, do you all notice that to the left of the y-axis there is no graph, right? So I should have no derivative there as well. So my derivative, when I draw it, should only exist over here, and it should always be positive, which means it should always be above the x-axis, right? Now, what's it going to do though? I mean, we need to kind of like wrap our heads around what's happening here. As I move to the right, we already said it's positive slope. Are those slopes getting steeper or are they getting flattening out?